So today I'll ask you a couple of I'll ask you a coding question, and if we have time, I'll ask you like a second coding question.
Mhm,
And the main thing that I do want to say is I do not care. I mean, I don't care about syntax that much.
mhm,
All I really care about, I mean, I care about a lot of things, but what I really want to see, where I really want to see you shine is like
mhm.
in the way that you communicate. I want to see you
Okay.
communicating clearly. So yeah, I
Mhm,
guess at first I'll ask you these two questions, and after
mhm.
that, at the end, I'll kind of tell you about my 8 step process to kind of just like passing any coding interview and stuff like that. And
Perfect.
also tell you about what went well and what could have gone better. It's not about the question, and it's not even about you getting the question, I guess, like you writing the right syntax for the question or you even knowing how to code at all. The
Mhm.
main thing that I really want to see is two things like efficiency, communication, and I guess a little bit of speed as well. The first question I'll ask you is this. Okay. So you're given a sorted array of positive integers and an integer k. I want you to find the pair of numbers whose sum is closest to k. And this sum can be equal to, less than, or greater than k. And all I want you to do is just return the pair. For example, you have this input, which is like a 5, 8, 14, 17, 25, and k is 35. And the right answer would be 8, 25.
Mhm.
Reason for that is 8 plus 25 is 33, and that's the closest to 35.
I see. Perfect. Let me make sure I understand the question correctly. So basically, I want to find two number, and then I should return this sum, right?
No, you would
I'll
return,
return the two number.
yeah, return the two numbers, yeah.
I see. So I return the two number that has the sum that are closest to a given number k, in the input.
hmm
Um, Perfect. So, I mean, can I assume that the input always have at least two elements?
Yeah, that's a great question. And I would say no. I think that's actually something that you should take.
Okay, so edge case first we have to check if instead have at least two elements then.
hmm
That's
Yes.
something I'm gonna check for first. Second thing, will I have to deal with your negative numbers or is it gonna be only non-negative numbers?
Yeah, no, because like I said, over here it says all integers are positive.
Okay, sounds good. So
But
no
but
negative.
but
I mean, I don't think it changed that much, but
yeah, but your k can be negative.
oh, K can be negative. Great.
hmm
Uh, in here, uh, K can be negative. I see.
hmm
Perfect. So I want to return the two number, and I want to make sure that their sum is closest to K. And then perfect. So I guess with this kind of problem, the brute force approach would be, you check every possible pair. So it would be like two, would be like a nested loop basically. You check every single pair, you record what's the difference between of the pair with K, and then you could record you basically record the answer with the minimum delta, and you store it in like in a variable, and then once you have iterate through all the possible pairs in the array, you can make sure to return the current answers you have. With that kind of approach, we'll be looking at O(n) square, where n is the number of elements in the array, and then obviously space will be O(1) because we only use like a answer variable to store whatever we have at that time.
hmm
um but I think we can definitely optimize it a little better. Instead of ON, we can do something. Sorry, ON square. We can do something like ON approach here. What I think of right now is we do some sort of like a two pointer. Where let me try to copy paste this so I can explain it. So because we are giving a sorted array, right? So I think we can utilize this thing usually like assorted features to kind of design our algorithm here. So I can have like two pointer I and j that starts from either end from the two ends of the input array, and then I'll calculate their sum. Basically I want to be like closest to k as possible. So, if the current sum, if I'll just if it is equal to k, then we can just return the two number, right? If the current sum is greater than k, so we know that, we have to make the current sum smaller so we can get closer to k. So, well, how do we make this smaller? Because these are the two like extreme ends. So we if you want to make this smaller, we have to, make one of the two numbers smaller, and the only smaller number we can get to is j, to make j smaller here. So basically, if I want to make the sum smaller, I will decrement j, and then I'll get to a new sum, and then I can check that sum again, and then, if the current sum is smaller than k, decrement j, and then I can increment I, because that's the only way I can do to make the sum bigger. Does that kind of make sense? And then in the end, I should have some sort of a combination that is the closest to k. Does that make sense?
Yeah, that makes sense. So how would you check that your sum is closest to k?
I see. So that's a great question. So to check if sum is closest to k, I can have like a variable to store, the current answer, I guess, or just ans for short. Uh, and I will have it like basically, I will keep checking. So let's say our current is so our k is 35. We wanted to return 33. We wanted to return 8 and 25 in this case, right? With that example, we have I and j start at 0 and 1, 2, 1, 2, 3, 4, 0 and 4. The current sum is 30. And we see that it's actually smaller than our k, right? So, let me write it down. So I equals 0, j is equal to 4. Per sum is 30, which is smaller than k. So I record as I guess I need to do as like a tuple. I mean, yeah, that's fine. We'll store it like that for now. And then we'll have this, and then because current is smaller than k, so we increment I, as I said up here. So we increment I, and so now we have 8 and 25, right? So 8 and 25 is 33. And we can check it by having a function where we check the sum of the two number recorded in S and the current sum of the two number that we're checking at the moment. So we see that the delta is actually smaller because 35 minus 30 is 5, whereas 35 minus 33, our current sum is only 2. So we'll change that to 1/4 here, and then we can go up because it's still smaller than k, so we're actually going to still keep going up. And now we get 14 and 25, so it's gonna be 39. So the first time is 39 is really greater than k. And we check, so the current delta would be 4. And the current delta is actually greater than what I have right now. So I can actually break this loop right here because I know that no matter. Oh, actually, no, I can't. So it's 39. It's greater than k, so we're not going to change the answer. So the current sum is greater, so we're going to decrement j, right?
Mm-hmm.
And then when we reach this step here, we're going to get to the current sum will be 31, right? I equal 2 and j equal 3. So we have the current sum will be 31. 31 is smaller than k. But my current delta is 2, whereas my smallest delta is 2, and this delta is 4, so we still not gonna change my answer. And then it's smaller than k, so we increment j. We increment I, and now I and j is equal to each other, and it's gonna be at 3. This is when we break the loop when I is equal to j. And then once we finish the iteration, we should have the answer as a number of index 1 and 4, which is 8 and 25.
Okay, cool. I guess the question that I wanted to ask was just like, how do you calculate the delta?
Oh, that's so I will take the sum of the two number, array at I and j, array at j, and then minus k. Obviously, we have to make sure we are doing this in the absolute value,
Yeah.
because we want to make sure that we, is the difference. So it could be smaller or larger. So we have to make sure that we do the absolute value.
Okay. Awesome. Awesome. Sounds good. Sounds good. And now, so how would this decrease the time complexity? What would the new time complexity be, babe?
The new complexity would be O(n) because we only go through every element in the array at most once.
Okay.
Because like at each step I either decrement j or I increment I. So it should be O(n), time complexity, and space should be O(1) because I only have, 3, 4 variables most.
Okay. Cool. Sounds good. Sounds good. Whenever you're free, you can start coding it whenever you're ready.
Perfect. So good. I will just type it down here. I will have my function. No, I here. Close it. And then I have an input as my array and a number k. Right. So we have to make sure that, as I said before, there's an edge case where the input there's not enough elements in the input array. So we have to make sure if length of array is smaller than 2. What should I return in this case? Do I return like a nothing, or should I return an empty tuple? Um,
Yeah, that's a great question. What do you think we should return if let's say a user gives you an invalid input? What do you think we should return?
I usually return something that can flag as an invalid input. I can rate exception here as like invalid input, or I can just return like an null, or I can return, yeah, an empty tuple. That's I think would be the best case, just to flag that we don't have anything
Okay.
on.
So actually, I think what you said, I think raising an exception would be the best, but I think for now, you can just return none.
Okay, I've returned none. Now good. Perfect. So that will be the edge case we want to make sure we get. We have our I, we will initiate I and j equal to 0, and length of array -1. That's the 2 index. I have my current ands will be none, and yeah, I think we only have delta 2. I think not really necessary, but we should set it to none right now. Okay, so our loop will keep going when I is smaller than j. That's our condition. To keep the loop going, we'll break the loop. So basically, we'll have to check curve sum will be the total sum at index I plus the number at index j. And then we want to check if curve sum is equal to k, we had to return immediately because we wouldn't have any other combinations that could have any smaller kind of difference basically because it's equal to k. So we can actually return array at I and array at j. Aleph current sum is smaller than k. So in this case, right, so if current sum is smaller than k, we want to make the sum bigger. So here we will increment I, but before we increment I, we have to check the current sum and the delta to see if it's smaller, and then we replace ands. So basically, if not ands, we're just gonna record this as our current answer. Ands will equal to this. Else we have to check if our current delta is smaller
Okay.
than the recorded delta. So if ABS of array at I from array at j minus k, it is smaller than delta, then the record our new answer, basically. And then we have to upgrade our delta to he is gonna be this part here. Yeah. And then we increment I. Oh yeah, no, we increment I over here. That's correct. Yeah. And then this is the case where current sum is greater than k, right? So, oops, sorry. So again, if not answer, we still want to record this as our current answer, as our most because closest we can get. And then if not, then still we still want to make sure that we report the new delta that we have. So if this is correct. So if the current total minus k, the delta is smaller than our current delta, we record our new answer and we update our delta accordingly. But in this case, instead of increment I, we'll decrement j. And then the loop will keep going back until we have I equal to j, and in the end we should return n as our final answer. And yeah, I think that should work.
Okay. Okay. So is there anything you can do to like make your code, I guess, more efficient? No, well, yeah, it's not efficient, but
like cleaner, shorter.
yeah, a little cleaner. I think there's something that's catching my eye.
I see. Great. Let me do real quick. I guess this outfit is a little like a little lengthy kind of. So instead of this itself segment, and instead this delta.
Or actually, no, I mean
That's
the
fine.
thing is- no. The thing is, look, you're doing it twice, right?
Mm-hmm.
You don't need to do it twice.
Oh yeah, that's what I mean. So I don't actually have to do it twice. That's actually a great idea. So we'll do this and move this up here. So basically we'll do this every time. And we'll increment or decrement j based on whatever we have. So let's say if cursor array I plus array j is greater than k. Sorry. J decrement j, and else we can increment I. Does that seem better? Because I only do this once and then I change it after.
Yeah, yeah, that's much better. That's much better. Cool, cool. I mean, you could also instead of Ri plus Rj, you already have like a first sum as well.
Oh yeah, that's right. That's true.
Yeah, that's fine.
Yeah, I can just change
Okay, cool. And then you already said the time and space complexity, which is O of n and O of 1. That's
it.
good.
Yeah, that's right. Oh, and no one.
Cool. I think now, so at Meta and Google, we turn off the run button. We never want people to run. Instead, we ask people to do a dry run. So, can you do a dry run?
Yeah, for sure. Would can I do that with a given input that you give me, or you want me to try it within like another different
Yeah,
unit input?
use it. You can use either the given input or you can use your own. It doesn't matter to me. Anything's fine.
Okay, that's it. I can just use the given input, so I should paste it here so I can keep track of that. So first thing in the call, we check if the length of the array is smaller than 2. In this case it is 5, so we don't actually execute this block. So we're gonna go to this one right here. So we have I equal 0, j equal 4 in this case, right? And then and will be none. That's what the initialized to. Delta also will be none. Perfect. So right now j will be equal to 0 and j equal to 4. So first our cursor will be array I plus array j, which is 30. 5 plus 25 is 30. That's our cursor. Cursor is not equal to k, right? K is 35. So cursor is not equal to k, so we're actually not gonna be executing this block. We're gonna go down here. So if not and, so we don't have any answer. So we update and to be 5 and 25, basically. Um, uh, so, and then we move down here. Current sum is 30, which is smaller than k, so we want to increment I. So I would be 1. And j will be the same. So right now, I 1, j is 4. Current sum will be 8 plus 25, which is 33. We have 33 here. So current sum is not equal to k, so we're not gonna, do anything. We're gonna go down here because our ant exists, so we actually want to execute this block here. We have, the sum is 33 minus 35, which is minus 2, and the absolute value will be 2. And a small, I should have the delta here too, because delta is none, because I didn't record delta in this line. So delta will be basically this. So I have so now I have delta, which is 5 plus 25, 30 minus 35. So it's gonna be 5 right now. So my delta is 5. And the current sum is 33 minus 35 is 2. So because 2 is smaller than 5, so we actually want to record our new answer as 8 and 25. And our delta will be 2. Right. And then, the current sum is still smaller than k, so we still want to increment I. So I will be 2. So we have I equal to I equal to j equal 4 here. So the current sum will be 39. So 39. The 39 is not 35, so we're not executing this again. We have our answer, so we're gonna check this block here. The current delta is 39 minus 35 is 4. And our current delta is recorded as 2 here. So it's actually not smaller. So none of this will be executed. We'll just move straight down here at this block. Because our current sum is greater than k, so we want to decrement j. So we have j equal 4 up here, so j will now be equal to 3. So we go back to our loop again. So we have I equal to j equal 3. So the current sum will be these two number, which is 31. And then it's still not it's not k, so we want to check these ones because our ants existed. So again, we check into this block. So the delta with 31 and 35 is 4. But the current delta is 2, right? So this will not be satisfied. So we're not gonna execute anything in here. We're gonna go down here again. So we have 31 smaller than 35. So we actually want to increment I. But then I equal to j. And the condition for our loop no longer is no longer satisfied. So we break out the loop and we return our current answer, which is 8 and 25, which is the expected answer for this problem.
Mm-hmm. Okay. Cool. Yeah, I have a couple of questions for you.
Mm-hmm.
So I guess what would your code do if there were, let's say, two closest values? For example, there's 825 and there's also, I don't know, 1419, is that right? Yeah.
Mm-hmm.
So what would your code return?
My code will return 825 because I only updated when the new delta is smaller than the current delta. So because 1419 will be basically after 825 because the iteration goes inward, right? I start ing, so it's gonna be processed after, so it's gonna record 8 and 25.
Okay, cool. And then the other question I have for you is what would your code return if k was smaller than all of the values in the array? For example, k is like 2 or like k is like -5 or something like
That's a great question. I actually thought about that before and then I forgot. So is k smaller than all of the possible number? If we return the first two elements here, that's like the closest we can get. Because we know I actually thought about it. So because we know that our array only consists of positive non-negative numbers, so we actually can make like another case, where if k is smaller or equal to 0, we can actually return uh immediately array at 0 and array at 1, because we know that it's only gonna get bigger and bigger and bigger with whatever number is after the first number here, because the array is sorted.
Okay. Cool. Cool. Awesome. Awesome. Okay. Cool. Yeah. I think we're good on this one. I think you came up with the edge spaces. So
Mhm.
good job. Yeah. If you're ready, we can move on to the next question.
Yep, perfect. I'm good.
Cool. Cool. Okay. Here is the next question. Oh, let me give you some few examples. Okay. Here's the next question. The next question is, you're given the root of a binary tree, and I want you to imagine that you're standing on the right side of it and your best friend is standing on the left side. You both observe the tree from your respective sides. I want you to return the value of the node that you can both see. So what I mean by that is, first output the nodes from the left side view in bottom to top order, then
Mhm.
output the nodes from the right side view in top to bottom order, and just kind of combine them. For example, if you look at this example one, you'll see on the left side, your friend be 125, where I want your friend to return it as like 521. And on your side, we can see a 134. And then the output, I want you to combine them. So you combine 52134.
I
And same thing on the example two. Your friend is standing on the left side. He sees 1245, but he has to return bottom up. So it's 5421. And your view is 13. So, but you return 13. And you find 54213.
I actually have done this question before. I mean, I'm not sure if that's the most optimal way, so, but basically we do a level order traversal, and we want to have two separate arrays to store the left side and the right side. In the end, we should split the left side and combine the right side and minus the root. I think that's what I was gonna do in the problem.
Okay, cool. Yeah, I think that would be it. But there's actually a couple nuances in this that actually could get you. Let's try the problem, and I'll ask, and then you'll kind of see what I mean.
Okay, show some good. I guess you do it. Nope.
Yeah,
Correct.
I'll let you know. There's like more to it than meets the eye. If you could find out this thing, then let me know. But yeah, go ahead. Go ahead.
Perfect. So I'm just gonna approach this as I haven't known anything. So okay, for this kind of problem, you want to see both the left and the right side, and you want to basically have it like level by level. So basically, the best way to approach this would be some type of like a level order traversal in tree. So basically, we will go from the first level, which is the root, and then we go down and down. We keep processing the next level until we don't have any elements. So it should be a type of BFS traversal, and to do this, I will implement like a queue that store a double-ended queue. So, I mean a queue, but in Python he uses a double-ended queue. So that goes start from the root, and then I'll traverse um this queue until there's still an element in it, and then I will have basically um I will check the current index of the element in within the length of the queue, so we know that let's say start at the first element is the root in this case, right? So we know it is the leftmost element if the index is 0, and we know it is the rightmost element if the index to relative to the queue is gonna be n minus 1, which where n is the number of elements in the queue when we process it when I first process it. So basically we check for current index if I equal to 0, so it belongs to the left side, and if I equal to n minus 1, it belongs to the right side. Um, and yeah, so in the end, I will have, once I traverse everything, so I have two arrays, which is 125 and 134. because I do a level order traversal, so it'll go from top to bottom. But so we want to do a left view bottom up. So we actually want to flip our array. So it's going to be 521 and 134. And then we want to make sure that our root only count one. So I will actually pop the last element from the left side because I know it's going to be the root. And then I'm just gonna append the right side view to it, and it should be 52134 after the final answer. So the edge case would be, where we don't have a tree, root didn't exist. So we just return an empty array then, I would say, because we can't see anything from either side of the tree.
Okay.
And for this edge case too, so this one, so we look 1, 2, 4, 5 as the left, and we have 1, 3, 4, 5 as the right side. Oh, you actually don't see anything on the right side. Oh, I see.
Okay, so actually,
Uh-huh.
that's actually the edge case that I wanted you to think about because
Mm-hmm.
even if you're so I guess okay, so I guess let's talk about this one for a little bit.
Yeah.
So you see here, let's say like a nine, but so
Yep.
what do you think would be the left view and the right? What would be the left view?
The left view would be 129.
Okay, it'd be 129, right? Okay.
Yeah.
So what if we did this? Okay, so what would be the left view for this?
Would it be 1298?
Yeah, it would be 1298.
I
But
see.
here's the problem. So I did this is what I said initially, right? I said the
Mm-hmm.
for this one I think it was a little confusing because I did say right view is 1 3.
Yeah.
But if you really think about it, right view is also 1 3 4 5, right?
Yeah, that's what I thought too. Because you still have two notes, and if you stand from the right side, you can still see them.
Yeah, yeah, and same thing here, right? The same thing
Yeah.
here. The right view be for this side.
Actually, 1348.
Yeah, yeah, exactly.
Mm-hmm.
So you would need a little bit extra processing before you finally get the answer. So how would you deal with that edge case?
Well, I think for my code it would actually be the same. Because I process all these levels, right? And then for the last level, my queue only have one element, which is this 8 here. And if I check, I equal to 0, so I append it to the left, and if I equal to n minus 1, which is n minus 1 equals 0, I will append it to the right. So I don't think that it matters for my logic because I only check like I don't do like an if else. I do just if basically.
Oh, okay, I see. Okay. Um, actually, can you turn that into code? I'm kind of curious.
Yeah, of course, sounds good. So I'm just gonna do it right here. So I'm gonna have my function as binary tree view. So I have a root. And I think that's the only input that I need, right? Um, perfect. Uh, so sounds good. And then I start with if the root doesn't exist, we're just gonna return an empty array. If you don't see anything, let's say above. And then we want to have our queue that has for I need to import collection. Import back. Correct. So that should be good now. And then I will do why my key to exist. I will check for I and n will be equal to length of queue, and for I in range of n. So this is where the indexing I said would be. And sorry, I need left hand side. Equal to 2 empty array to store my answer. Right. So for I in a range of n, so it will iterate from 0 to n minus 1, right? So if I equal to 0, I know it's in the left side. So left will append, sorry, I need to cur equal to pop left. Yeah, this is a q, right? Cur bow. Assuming we have a note class. I can implement that later, but let's say we have a note class that have, a tree note that has a value property. Yeah, and then if I equal to n minus 1, basically it'd be that is the last element in the current queue. I will have right append curd bow, and then I want to check if for child, I want to check their children to keep appending to the queue, and right in her left, her right. I want to append it to my queue. Append child. If child. Sorry, I need to check the child if child because I don't want to append any that doesn't exist.
No.
Yeah, it's a note doesn't exist. I don't want to process that. So yeah, so that should be it. And then I want to reverse left the hop because we want to create the root in the left function.
Okay. So you
Yeah, and then
So if you reverse you left dot top, does that get the end element or the first element? Sorry.
it get the right. So sure. Let me come back to this. So it starts at 1 to 9, I guess, up here. 1 to 9 8, right? So if I reverse it, it will be 8 9 2 1, and if I pop it, it will pop the last element of the reverse, which is the first element.
Okay, got it.
Yeah. So I return left plus right, and that should be the answer. I think the reverse is wrong, but yeah,
that works. But I guess
yeah.
so. So here's the question. Here's the question I have for you.
Yep.
If you look at your code,
Mm-hmm.
actually, let's go through let's go through this example. All right, actually,
Sounds good.
at 9 o'clock. Yeah, let's do a dry run because I want to see if you okay. Let's do a dry run and I'll show you what I know.
Okay, sounds good. I can try to go through a dry run. So with this modified one right here, right? So let me copy this tree so I can see. And yeah. So that's our tree there. So our root is node 1. So deck would be 1 here. Left and right will be 2 empty array. Right. Our root is only 1. Perfect. So while q still exists, so we have our q as the only element, n will be equal to 1. So for I range of n, so we only iterate this once because we only have one element here. So I will be equal to 0. Cur will be equal to q pop left, which is q pop left, which is this one right here. Let me just copy the q here so I can see. So that will be the root node. So we see that I equal to 0, right? So left will append curl bow. So this is left. We append it here. I equal to n minus 1, which is also right because n is 1, and 1 minus 1 is 0. So we actually satisfy this one right here. So right will also append curl bow. And then we check the left and right child. So we have 2 and 3 as their left and right child of the root node. They both exist, so P will be 2 and 3 here.
Okay.
Yeah, so then now the Q will be 2 and 3. Our length of the Q will be 2, um, because there are two elements in the Q, right? So we iterate from for I range of length of n. So I start at 0. The current node will be 2, and we pop it out of the Q. And then uh, sorry, where am I? So I equals 0. The current node is 2. Um, I 0, so we left append curl valve. So we actually append here to left. We know that 0 is not equal to 2 minus 1, so we're actually not gonna deal with this. And then we will check for the type of the current node. So 2 half the children is 9 and 5. So we're gonna append it to our current Q, and then we go back to the iteration. So I will be equal to 1 now, and the current node will be 3 because we pop the first element of the Q, right? And we know that I is 1, so we're not gonna append here. We're gonna execute this because 2 minus 1 is 1. So this is satisfied. So we'll append 3 to our answer, and then we check for the children of the node with value 3. So the left child exists, so we're not gonna append it. Then we append the right child, so which is 4 in this case. So we append 4. Because we already finished our iteration here, so we're gonna come back with our Q with this while loop right here, the other iteration. So the length of Q will be 3 now. And then I start again at 0. Current will be 9. We pop it out of the Q, right? And then because I is 0, so we append 9 to our left. And then we check for children of 9. So we don't have anything. 9 doesn't have any children, so our Q will remain the same after. So I will be equal to 1 now because of this loop. So when I equal to 1, the current node will be 5. We actually pop that. 1 is not equal to 0, nor it equal to n minus 1, which is 3 minus 1 is 2 in this case. So we're not gonna append anything. We don't want to append the current node to any of the left or right view. We want to check the children though. So 5 have the children as 8, right? It's the left child. So we're gonna append 8 to our current Q, and then so we're gonna have one last iteration for this one. So I put 2. We know that the current node will be 4. We pop this out of the Q. 4, not 5, my bad. So 4. So we have I is not equal to 0, but I equal to I equal to n minus 1 here. So it's gonna be 1, 3, 4. So you want to append the value over there. And we check the children. So 4 doesn't have any children, right? So we're not gonna do anything. And so we have already finished this iteration. We're gonna go back to this Q, to this outer loop here, basically. We see that Q still have one last element here. We change our length to be 1, and iterate from 0. Sorry. So here we have current will be 8, and our Q will be empty. So the current value is 8, and I is 0. So we actually left append curl valve. So it's gonna be 8 here. And we see that, I is also equal to n minus 1. So we actually also want to append it to the right. And 8 doesn't have any children. So, we don't
So,
any issue.
so this so this is kind of exactly the problem that I was kind of getting at, right?
Mhm.
Because you have duplicate, and I think maybe I wasn't clear enough. I think
Mhm.
the reason why you see it says 5421 and right view says 13 is because
Mhm.
we don't want any duplicate. We don't
So you don't want duplicate. I see.
don't want 8 on both sides. We want
Okay.
we want to pick one side. That's what I was saying. Like, okay, this 5421. That's why I took the example. The right view only has 13 because we don't want to have same thing.
I see. Yeah. Sorry about that. I didn't. Sorry. I should have
Yeah,
clarified.
no problem.
I mean, for that, then I think I can, instead of like a two extended, I can do an Alice here. So basically, it's only gonna append to either or if they satisfy both, right? So,
Mm-hmm.
for the last one, eight not gonna be there, you know, or even the first one is not gonna be here. So we don't even no, we don't have to pop from left because our root is not gonna be the our root is not gonna be repeated because we only append if or else if. So we can make sure that we only do one element
Okay.
at a time. Yeah, that will
Cool.
be the code then.
Yeah, that works. Cool. Okay. Yeah. 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 Are you done? Sorry.
Yeah. Oh, sorry. I should talk about complexity.
Yeah.
So for this problem, because we do a level order traversal, so the the maximum, space complexity will be the width um of the tree. I mean, but we don't have like a complete binary tree. So I mean, the worst case scenario, it could be um O(n) divided by 2, I think, but still it's O(n). Um, in the best case scenario, it could be O(1) because every node only, there's only one node in each level, but still, average out should be O(n). And then, for time wise, we are traversing each node at once, so it's gonna be O(n) for where n is the numbered node in the tree.
Okay. Cool.
Yeah.
Cool. And one more time. Do you have any other edge cases, or I think this might be good, but
Let me think if I can think of any other edge case. I mean, the edge case would be, root doesn't exist, or it'll be a very skewed binary tree. That will be one of the other edge case, but I think the code actually um deal with that. Uh, what do you think? Hmm, not tonight. Yeah, I think that's it. I don't really think of any other edge case.
oh yeah, yeah. No problem. No problem. I don't think there are any others.
Oh, okay. I was here for a second.
Okay. Okay. Cool. Cool. Yeah. Awesome. Awesome. And I guess this one of the questions, another question that I have
Mhm.
is I don't know. They usually ask this like dumb question. I hate this question, but I was going, oh, like, what would you do if like the tree doesn't fit in memory or some dumb question like that? But I don't know. Do you have an answer for that? Even I don't know if I have an answer for that. But if you do, I can like I'd be down to listen.
So basically, the tree doesn't fit into memory.
Yeah, that's a dumb question. Never mind. Don't worry about it. Never mind. I,
I mean, if you're only given a root node, I don't know. It's
yeah, I mean,
weird.
me neither. It was a dumb question. It was a dumb question.
Yeah.
Don't worry about it. For some reason, I get that question. I used to get that question a lot. I'm not getting it as much anymore. But I used to get that question for every time I got asked a question and maybe I finished early, they would always ask, okay, what would you do if this array doesn't fit in memory? What would you do if
Oh.
it doesn't fit in memory? And then I'd have to give them like a design answer. And I was like, dude, this is such a dumb question. Uh, But yeah, cool, cool. Yeah, great job. Yeah, sorry for giving you a problem that you probably have already seen.
Well,
But
that's fine. I think it's very good when I can see work with the different edge case and everything. And I do misunderstood the question, so I mean, definitely on my end too. So.
yeah, yeah, no problem, no problem. Yeah, and yeah, and I think overall you did an amazing job. You did a really good job. You communicated how I wanted you to communicate. And at the last couple of minutes, I'll kind of tell you what I see in all the interviews that I've done and what I think is like the process where I've seen the most candidates succeed following this process. And we'll go through these steps and I'll tell you like what you did and what maybe you didn't do.
Mhm.
But either way, I think you did an amazing job. 5 stars all around, so no
Thank
problem.
you very much.
But yeah, okay. So let's go through it. Okay,
Yeah.
step one would always be ask clarifying questions,
Mhm.
and you did ask clarifying questions. And I think the rule of thumb is try to ask at least 2 clarifying questions.
Mhm.
You always need to ask clarifying questions because you want the interviewer to think that they're smart, you know. And also let's say that I give you like a project and like
Mhm.
a whole project, and then you just go down and do the project. You didn't ask any questions, then I won't be like think that you understood the project, and I won't really have any trust in you completing the project correctly. So you did do a good job on that. I did see you ask at least 2 clarifying questions.
Mhm.
Uh, and and if you can't think of one, then just ask what to do for an edge case, which you also did. You also asked for that, like, what do I do if like less than 2 elements in the array?
Yeah.
Do it. The root is null. If you can't think of 2 good ones, then the second one can always be like, just talk about the edge case. Like, what should I do with this? What should I do with that?
I
So you
see.
did a good job. So good job on that part.
Mhm.
Step two. Step two, after clarifying questions, step two is always visualize the problem.
Mhm.
And you did do that part as well. So I did.
Mhm.
So you were writing down. You
Mhm.
were writing down, like you were taking notes, writing down, and this is the main thing that I don't see like a lot of people do, and this kind of makes me
Mhm.
feel like worried about some people. A lot of people kind of like just start going into the problem, or they don't really like visualize the problem. I saw you did a good job. You did take notes. You were like,
Mhm.
okay, so if I did this, I do that. Okay, Q equals DQ and stuff like that.
Mhm.
So great job on this part. One thing I will say, this is actually optional. You don't have to do this. I do see
Mhm.
very strong candidates doing this. You didn't really need to do it, but I also see a lot of the candidates that I've interviewed did this, and
Mhm.
we end up passing it. And you reason thing that they did is they write down the steps. So they write down the steps of
Oh, I see.
solve the problem. Actually, sorry. This is step three. Oops. Brute force solution.
Yeah.
A lot of candidates forget the brute force solution. They're just jumping in. This is actually I'm
Mhm.
looking at my rubric at Meta right now, and this is actually one of the things. This is actually one of the things that we actually test people on. Did the candidate
I
come
see.
up with the brute force solution and improve upon that solution? And
Mm.
second question, obviously, there is no brute force solution. But the first question, there is a brute force solution, and I'm really
Yeah.
glad you brought that up. So
Mhm.
great job. For this, you need one sentence. You don't even need more than one sentence, to be honest. But
I
uh,
see.
see, the problem with the thing about, I guess, Ripple interviews and other interviews is you get an hour for all of this, but if
Yeah, I do get an hour.
you get an hour for all this, but a meta interview, you get about 35 to 40 minutes. You have to solve 2 questions, right? So you
Mhm.
need to
Yeah.
find ways to like increase the speed, and you need to find ways where you can like decrease the amount of this, decrease the amount of that, and increase like this. So that's why
Mhm.
for a solution, it's okay that you could say in more than one sentence, but I would say for like a
Mhm.
meta interview, keep it at one
Mhm.
sentence. Say,
I
okay,
see.
we can solve this using this, but that would be O of n squared. But I think that we can do better. That's it.
Mhm.
So
Perfect.
yeah, brute force solution. You did do that. It's a great job on that part.
Mhm.
And the reason why I tell a lot of candidates to write down the steps of how to solve the problem, and these steps
Mhm.
don't even have to be that good. Here, I'll do it over here. So it'd be like step one, okay, what was it? Hold up, sorry. Okay, step one, 2 pointers. Step two, check absolute value minus k.
Mhm.
Step three, if sum greater than k, move left.
Mhm.
And less than K, I don't know, move right.
Right. Yeah.
Yeah, it doesn't have to be like an essay. You're a software engineer. You're not an English idiot, right? It's just
Yeah.
like a couple steps. And there's 2 reasons why I usually tell candidates to write down the steps of like what they're going to solve. You don't
Mhm.
read it because you did a great job, but I tell a
Mhm.
lot of other candidates. Oh, sorry. A
Mhm.
lot of other candidates that struggle a little bit to do this, and the reason why is 2 things. So let's say you wrote down the steps of the problem
Mhm.
and you wrote some code, and right after the interview I have to go through like 5 different meetings, and I have a lot of stuff to do, and I'm really stressed with work. And then
Mhm.
after 5 6 hours I come back to your code and I look at your
Mhm.
code, see a lot of the syntax is off, or I see the code and I see like some parts of the code that look kind of wrong.
Mhm.
Uh, if I see that and I don't see any steps, I'll be like, okay, I think she misunderstood the problem. She got the syntax wrong. Okay, probably have
Mhm.
to help her.
Oh.
But if I see the steps that you wrote, and then I see your code, and I see there's some syntax issues, I'll look at the
Mhm.
steps that you wrote, and I'll be like, hey, got the steps right. Maybe she did
Mhm.
get the syntax. She's got the syntax wrong a little bit. You know what? She still has the right idea, and she communicated well. So I think I'll still pass her.
Mhm. I see.
The other reason that I tell some candidates to write down the steps is because usually there's times where if you don't write down the steps, you'll begin
Mhm.
to code, and obviously the stress of an interview is a little bit stressful. So you begin to
Mhm.
code and you kind of forget what you're doing as you code, right? Being
Mhm.
like,
Yeah.
what do I do now? What do I do here? Oh, I totally forgot, blah blah blah. So you
Mhm.
kind of forget what you're doing as you're coding because of the stress of the interview. And these steps will kind of be like, oh, okay, okay, this part I got to do the 2 pointers. Okay, this part I got to check the absolute value.
Mhm.
And the last thing is, sometimes talking while coding is kind of like difficult, but you did a great job. You do a
Mhm.
great job on that. So for some people, talking while coding is difficult, and this kind of gives people like a good kind of script.
I see.
So obviously, you don't have to do it if you don't want to. This is
Mhm.
optional, but I do see my strongest candidates doing this, and
Mhm.
um, and yeah, and it can help, but also you have to look at the time, right? If you only have like,
Yeah.
don't worry about doing it. Right? You have a
Mhm.
lot of time. Okay, go ahead, do this.
Mhm.
But pretty clear. But overall, you don't need to do it, but it's an optional thing, and that's just what I tell candidates.
I see. That makes sense.
Cool. And step 4, after you like visualize the problem, you take notes, you write down the steps of how to solve the problem. You always ask, "Can I code now?" Or
Mhm.
"Can I code now?" Or "May I begin coding? Can I start coding now?"
Mhm.
And the reason why you always want to ask this is because or like you said, oh, okay, are we good now? Like, or do you understand? The reason why we want to ask this is because if you don't ask the interviewer how they're feeling, we're just gonna
Mhm.
you're overconfident and you don't want to listen to the interviewer. Because a lot of
Mhm.
times the interviewers they really want to ask you a question, right? They want to
Mhm.
be a when you ask, can I code now? Usually some mean interviewers they'll ask you a bunch of like dumb questions like, oh, what about this? Or they'll try to like trip you out for some reason.
Mhm.
And you want to let them do that to you, or else you'll get docked a couple points, being like, okay, I can't work with this person. They're overconfident.
Mhm.
They didn't allow me to speak. So you want to have a pause, allow the interviewer to like digest what you said, and then ask you questions.
Mhm.
Need to ask you questions, and if they don't need to ask you questions and you're very clear, okay,
Mhm.
go start coding. So
Okay.
you did a good job on that part as well. So step 5, obviously, begin coding and
Mhm.
explain your code as you're coding.
Yeah.
So obviously, you don't need to explain every single line of code, but
Mhm.
you can just explain, okay, so this part I need to like, okay, this part I need to go through the queue. Okay, this
Mhm.
part, if it's the first element, and then if it's the last element, I'll append. Okay, boom, start coding that. Okay, this
Mhm.
part, then now I need to do like a for loop. Okay,
Mhm.
you just need to do that. You don't need to explain every single line of code. You kind of
Mhm.
explain like Just explain like yeah, just explain like an excerpt, like a little part of the code, code it, part of the code,
Mhm.
and stuff like that, or do it during that. That's great. So,
Mhm.
job on that part. So step 6, right after you code, try to come up with, try to come up with 2 edge cases yourself. If there's only
Mhm.
one, come up with one. But after you're done coding, you should always try to come up with the edge cases yourself because
Mhm.
if the interviewer comes up with the edge cases before you come up with an edge cases, that's unfortunately they'll dock you a point because they'll be,
Mhm.
oh, she didn't really think about the edge cases. I had to come up with the edge cases, and I had to,
Mhm.
plot her to think about the edge cases. Or please, yeah, try to come up with your own edge cases. Try to come up with at least 2 edge cases if you can.
Mhm.
Um, there's only one. Sometimes there's none. That's totally understandable. But try to come up with your own edge and be quick because if you want to come up with these edge cases before the interviewer comes up with the edge cases.
Mhm.
So yeah, so that part, and then step 7, obviously either dry run or Yeah. Or if they step seven is actually planning very bad. Time
Yep.
place. You did a good job on that part. So no qualms about that. And final step is dry run, or some places make you run the code.
I
So,
see.
yeah, it depends. So I guess Meta, Google, they don't make you run the code. The run button is always like grayed out.
Mhm.
Uh, but yeah, so you usually have to do like a dry run, and then usually for the dry run, I tell my candidates to do a dry run right next to the code, and you did
Mhm.
it, and you did exactly that.
Yep.
So overall, I wrote all of these steps to kind of just say you did everything damn near perfectly.
I see.
Oh, I think if you follow what you did today,
Mhm.
like I said, I don't at Meta, I don't care if you know how to code. I mean, I guess I do a little bit. I don't care about syntax. Like even
Mhm.
if you said reverse left, like you said, maybe it's not reverse left, I would have not cared at all, you know?
I see. Mhm.
But yeah, that does not matter at all.
Mhm. I see.
So what that is saying is about your communication, and what matters to me is, can I work with this person or not?
Mhm.
And how I can tell if I can work with you or not is based on how you treat it.
I see.
So yeah, overall, great job. Really, no, I don't have too many pointers for you. I think you did amazing, and I think if you just follow the steps that you already did today, I
Mhm.
think you do well in any interview you ever do. So yeah,
Awesome. Thank you very much for the feedback. Appreciate it a lot.
cool, cool. Yeah, I guess, yeah, cool. Do you have the Ripple interview next week, and that's it?
Yeah, I that's the only interview I have scheduled for on next Tuesday.
Is it Ripple or Ripple?
Rippling, rippling.
Rippling. Oh, okay,
Uh,
Rippling. Yeah, okay. I hadn't
yeah,
interviewed, but well,
yeah, it's a startup ish.
I know Rippling.
Yeah.
I interviewed with Rippling as well.
Oh, okay,
So
you did. Okay.
the problem with Rippling is I don't know if they still do this, but I think they do more real world problems. You know what I'm saying? Is that what they said?
Yeah, I thought so too. I mean, the I did the OA, and in the OA there was a bit of like a parsing, request kind of JSON file stuff.
Yeah.
But then I think in the interview they said it's gonna be more Fleetco style question.
Oh, they
Um,
did. Okay.
yeah. So obviously they might have follow up that relate to design, but I think in the core coding question it should be more leak code.
Okay, okay, cool, 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 cool. Awesome,
Mhm.
awesome. I remember I think I did an interview with them. It was lead code style, but then they said they didn't care about time complexity. They just wanted
Mhm.
me to parse things and like, yeah, they didn't care about time complexity that much. So I was like, oh, that's kind of cool. But maybe it's different now.
Mhm. Well, I mean, I try to do some research to see like what people have been interviewed like recently. It
Uh-huh.
seems to be very much coding question.
Okay.
Uh, I haven't seen any like parse JSON or design this, design that, or maybe it could be different for higher level interviews. Because I only interview for interns, so that could be.
Oh yeah, yeah, that's true, right? You're interviewing for
Mhm.
okay, sorry.
Yeah. So I don't know design, so.
Yeah, yeah, okay, that's cool, that's cool. Yeah. And remember that if they ask you a design question, it's always gonna be the same thing. What's it gonna be? If something doesn't fit in memory, what do you do? Just always think about that. That's the question every company asks if you finish too early.
Okay, I would definitely try to think about that.
They always ask that question, but I don't think you need to think about it as an intern. I think you'll
I see.
probably like later, so you're good.
Mhm.
But yeah, cool, good job. I don't have any more advice for you. I think you did amazing, and I think you'll kill it in your interview if you do the same thing. This 8 step process,
Mhm.
which you followed almost exactly,
Mhm.
is all you need for any coding interview ever in your life.
I
That's
see.
cool.
Perfect. Thank you very much for your time, for your advice.
Yeah, yeah, and I guess last thing is
Mhm.
here's two things. I think when you're far away from the interview, I think you've already been doing this, right? I think if you just do I think I just needed just did the problems of this neat
Oh,
code.
Nico.io? Yeah, I know neat code.
Yeah, yeah, I just did the 75, and that when I finished that, I went to the neat code one.
150?
Yeah, I think those are the best.
Yeah.
I mean, skip the DP, and I always skip the what's it called? The little these.
Binary out of a bit manipulation or
Oh, I hate those. I always pray that I never get those.
yeah, no, I did actually go through bit manipulation in DP too, so
Oh, you
I
did?
think
Good
yeah,
job.
I'm that deaf rate, so
Okay, okay, yeah. The bit manipulation I always skip, and I always pray that I never get it, and I never get it. I've got
that's great. I never wished to get it. So like I did have to kind of try to explore. I did have to do like a few problems. I'm not a god of it, obviously not. But like I need to at least understand what's going on.
yeah, yeah.
Yeah.
Okay, okay, you're good. So that's what you do if you have a lot of time, and I think you did that. It's a good job. And closer to the interview, always just lead code discuss every day. Lead code discuss. Check if there's any new rippling interview questions.
Hmm.
Look online for rippling interview questions. Just keep looking online, just as much as you can. Just look online for any like past interview questions as you go closer and closer.
Hmm.
And I guess the last thing I want to say is this thing is a numbers game, right?
Hmm.
Uh, I would also honestly say interviews are 60% luck and 40% preparation. The reason why 60% luck is because you can do everything right, but your interviewer can like wake up on the wrong side of bed and just decide to be an asshole that day.
Hmm.
Oh, he can just be like, okay, you know what? I'm gonna wake up and I'm gonna give this person a DP plus bit manipulation problem. Or you can do something right, and the interviewer will be like, "No, that's wrong. This is not. This is the way I wanted you to do it, and because of that, I'll fail you."
Hmm.
So the thing is a numbers game. So don't get discouraged if something doesn't go your way. Just keep clicking apply, and sometimes when you think you did really well, it might not go well, and sometimes when you did really bad, you'll get the job. So you never
I
know.
see. Yeah.
Good luck. You got this. I think if you follow what you did today, you're good.
Thank you
But
very much for the feedback. I really appreciate them.
but yeah, cool, cool. Good luck, and I'll
Mhm.
see you another time.
Okay, I'll see you now. Bye bye.
Bye.